Welcome. Let's take a look at the derivative of the natural log function and see how it can be used to establish the derivatives of other functions that involve the natural logarithm. So to start with, the derivative of the natural log function is in fact 1 over x. Welcome. Let's take a look at the derivative of the natural log function. Let's go ahead and get started by first of all observing that the derivative of the natural log of x is 1 over x, provided that x is positive. So from that knowledge, we want to establish what is the derivative with respect to x of the natural log of u. Now, we need to understand that when we say u here, we're looking at the chain rule, and we're assuming that u is some function of x. So by the chain rule, we know that we take the derivative of the outside function and then leave the argument alone. Then, after we take the derivative of the outside function, leaving the argument unchanged, then we multiply by the derivative of the argument. So in this case, in our first example here, our argument is a function u of x. So when I take my derivative here, the derivative of the natural log function is 1 over x, or 1 over the inside, or 1 over the argument. And then we're going to multiply by the derivative of that argument. In this case, our argument is u, and so we're going to end up with 1 over u times u prime, which we could also write as u prime over u if you choose. Either one is fine. So that's the derivative of the natural log of u. Now let's look at how do we deal with the derivative when our logarithm is some other base, some base b. Well, what we're going to do is we're going to take advantage of a property of logarithms, and that is this change of base formula that says log base b of a function can be written as a logarithm in a different base, a base a. So it can be rewritten as log base a of f and log base a of the base. So log base a of the function divided by log base a of the original base. So what we're going to do is we're going to use that to help us rewrite this log base b of x. So we're going to be looking at what is the derivative. Now when I switch bases here, I want to switch it to a base that I already know something about. And in this case, we already know how the logarithm for base e behaves, so it would make sense to switch this logarithm to a base e. So using this change of base formula, we'll go ahead and rewrite log base b of x as the natural log of x over the natural log of b, our original base. And now this natural log of b is a constant, so we can use the constant multiple rule and rewrite this as 1 over the natural log of b times the derivative of the natural log of x. And now we do know how the natural log of x, what its derivative is. So we're going to get 1 over the natural log of b times the derivative of natural log of x, and that is 1 over x. When we multiply those two, our numerator is 1 and our denominator will be the natural log of b times x. So the derivative of log for any base of x is simply 1 over the natural log of b times x. Now, in this last example, similar to where we had the natural log of u, we want to find the derivative with respect to x of log base b of u. And again, we will be thinking of u as though it were a function of x. So u is a function of x. So we can go ahead and apply what we know about the derivative of log base b of x. So the derivative of log base b of u is 1 over natural log of b times the argument times the derivative of the argument. So notice that log base b of x, the derivative was 1 over natural log of b times x. In this case, instead of x, we have u. So it's 1 over natural log of u, that is, we leave our argument alone, and then we multiply by the derivative of our argument. So u and u are placed where the argument goes, and so we end up with 1 over natural log of b times u prime. And that is our derivative for log base b of u. So let's look at 2 quick examples. In our first example, we want to find the derivative of f of x equals 2 times log base 5 of x. So f prime of x is going to equal, and notice we have this constant multiple of a logarithmic function, so we'll use the constant multiple rule. So we're going to have 2 times the derivative with respect to x of log base 5 of x. And then now we can go ahead and use our rule for derivative in a different base than e, so log base b of x, that's the rule we'll use here. And what is our base? But our base in this case is 5. So we will have times 1 over natural log of 5 times x, which is 2 over natural log of 5 times x. And there's our derivative. Let's look at our second example. Our second example, we have f of x is the natural log of 6x squared. So we're working with the natural log function. So notice though that our argument is not simply just x, but it is 6x squared. So we will be using the rule for the natural log of x, but since this is not simply an x in the argument, we will also need to be using the chain rule. So our derivative, f prime of x, equals, now recall that the derivative of natural log of x is 1 over x, or 1 over the argument. So our derivative here is going to be 1 over our argument times the derivative of our argument, 6x squared prime. And our argument is 6x squared. So continuing, we get 1 over 6x squared times, now the derivative of 6x squared is 6 times 2x to the first power So our f prime of x will be 12x over 6x squared. So 12x over 6x squared is our derivative, and of course we can simplify that just a touch more by dividing out an x from the numerator and the denominator, in which case we would end up with 12 over 6x. Also a representation of our derivative. I hope this is helpful.